Hello everyone, welcome back to What's Inside. Hopefully you enjoyed episode 1, but today we'll be going into something more interesting, I'd say. 1,000 brains, this is what you actually see. This is the LCD screen. William could tell you a bit about it.
Yeah, so there is a display right here, and what it does is that it displays any characters such as letters, numbers, whatever you want it to display. And what it does is that it has a couple of other components here, and for example, it will collect data and send the data to this piece, and it will ultimately display whatever characters you want it to do.
As you can see, there are 16 pins, front and back, and there are resistors. I'm not sure if you can see really clearly, capacitors, and 2 ICs. But yeah, let's get into the analysis.
Hey everyone, welcome back to the analysis portion of the LCD 1602. So just a quick recap, this is going to be your LED screen and it will display characters on this 16x2 grid, and it comes with a PCB mounted HD 44780 LCD with a parallel interface. And so why does this text output actually matter? In some systems, we can't always plug it into a monitor or debug from a computer. And we need something low power, easy to read, self-contained, character-based, and human-friendly. That's why displays like the LCD 1602 are iconic. They let your microcontroller talk back by showing values, messages, menus, and more. From thermometers to robot status screens, this is your go-to visual output.
So, what is the LCD 1602 actually? It's a 16-character by 2-line alphanumeric display based on the industry standard Hitachi HD 44780 controller. It includes 2 lines of 16 characters, see it right here, 5x8 pixel matrix per character. There's a white or yellow backlight, as well as a parallel data interface, which is 4 or 8-bit. There's also a built-in ROM, 208 ASC2 characters, and user-definable characters, which are up to 8 custom glyphs. And now let's get into each of the little subsystems. There's the liquid crystal display tech right here, which is a cross-section animation of an LCD segment. Each character cell is made up of a 5x8 dot matrix, 40 pixels total, behind polarized glass layers filled with liquid crystals. Here's a magic. No voltage means LC molecules are aligned and light passes through, and then when voltage is applied, molecules twist and light is blocked. By selectively controlling voltage to each pixel, we can turn on and off tiny black squares to build characters.
And then moving on to the HD 44780 controller. So these little black blobs or black circles are the integrated brains behind the display. And what it has, it stores the character ROM with all glyphs. It drives individual segments in a timed loop. It interprets commands like clear screen, set cursor, or print characters. And it supports both 8-bit and 4-bit parallel modes to reduce wiring. The host MCU, like the Uno, doesn't control pixels. It just sends ASCII codes or commands to this chip, and it handles the rest.
And then let's see the pin breakdown. So pin 1 is the ground, of course. Pin 2 is the VCC, which is plus 5 volts power. Pin 3 is the VO. Pin 4 is the RS, which is register select. Pin 5 is the RW, read write. Pin 6 is the E, enable clock signal. Pin 7 through 14 are the D0 to D7, which are data lines. And then pin 15 is the LED plus, which is the backlight power. And then pin 16 is LED minus, which is the backlight ground. Now, only 6 pins are needed in 4-bit mode: the RS, the E, and the D4 through 7, saving GPIOs. Now let's get into the contrast and backlight. William can tell you about it.
Yeah, so pin 3, the VO, adjust contrast, and it's usually wired to a 10K potentiometer to manually tune visibility. And the last two pins, 15 and 16, drive the backlight. Some modules use a current limiting resistors, while others rely on external series resistors. So without proper contrast, your characters either disappear or smear out. It's a very analog setting.
Yeah, of course, as always, there will also be a ton of more components like the command set, the character ROM and the CGram, and the 4-bit versus the 8-bit mode, as well as the physical construction, the troubleshooting, and the practical applications that we could all go over for hours and hours. But right now, I'm gonna leave you with a powerful message. This thing had the potential to change the world, and it did. Through this screen, machines were able to show us, to actually show instead of telling us. And so hopefully that leaves you with a lasting message. Hopefully that shows you how important technology is. And thank you for tuning in to this episode 2 of season 3, What's Inside. As always, we ensure you to stay curious because that's what's inside. Thank you.